beginning of third half hour, 22nd of July, Group software to start.
Okay, you've got to listen very carefully to this one. Okay, so this is the other kind of speciation, and it is called sympatric speciation. Not allopatric, sympatric. Okay, and my way of remembering which one is which is like this, and it's going to sound pathetic, but it's a good way of remembering, and maybe you will remember it in the matric exams. So here's a little snapping shrimp over here, and here's a little snapping shrimp over here, and she's beautiful, and he's a hunk, and he really wants to mate with her, but there's a land barrier, and he's calling across to her, hello, hello, but he can't reach her. Okay, so they can't get together, they can't mate. Allopatric speciation. Okay, but there's a barrier, geographic barrier that prevents them from mating with each other. Now, sympatric speciation is not that easy to understand. And what happens is it's the genetic divergence within a population from the same parent species. So they're in a population, they're together, they mingle with each other, but they inhabit an area, but the two groups cannot interbreed with each other, or choose not to interbreed with each other. I need to give you an example for you to understand that. So let me do this example first, and then remind me to go back to the orca. Okay, so there are trees that are indigenous in North America called hawthorn trees, okay? And they produce little berry-like red fruit. And there are tiny little flies that live on those trees, and they lay their eggs in the fruit. And their larvae develop in the fruit. And these little flies are called apple maggot flies. The maggot being because the little larvae develops in the fruit. Okay, so they're called apple maggot flies. And they lay their eggs. They're indigenous to North America. They've lived there for however many thousands and millions of years or whatever. And they lay their eggs on hawthorn fruit, and the young, the little larvae, burrow out of the hawthorn fruit, but they've eaten the fruit as they burrow out. Okay.
It's not in South Africa. Like, it's just, it's fine.
North America, were you biting some of your food at the time when I said this?
Yes, you're like, what? Apples.
Okay. All right, we're happy, we understand this concept. Okay. And then along came some immigrants that moved to North America from Europe, and they thought, oh, we really miss apples. And so they imported some apple trees. So apple trees with apples, not to be confused with hawthorn trees and hawthorn fruit. And these apple maggot flies are able to lay their eggs on apples, just as they used to be able to lay He's going to be looking carefully at that apple before he bites into it again. Okay. Anyway. And what's happened is, over a period of time, the apple maggot flies that lay their eggs on apples, their offspring no longer mate with apple maggot flies that were raised in hawthorns. It's like you from the south of Joburg, we're from the north.
Then what's the reason why they don't mate?
Exactly. Sympatric speciation. They
don't like
you're just different. You listen to different music.
Will those apple maggot flies that lay eggs, they were born or whatever in the hawthorn trees, continue to lay eggs there and not on apple trees?
Yes. They have preferences. So the ones that were raised in hawthorns lay their eggs on hawthorns. The ones that were raised in apples lay their eggs in apples.
And they won't like.
And they won't mate with each other. They're able to mate with each other. Under certain circumstances, they will mate with each other. If they're isolated and that's their only option, then they will. But okay, all right. So females generally choose to lay their eggs on the type of fruit that they grew up in. Males tend to look for mates on the type of fruit that they grew up in. Okay, so they generally end up mating with other hawthorn flies. If they're hawthorn flies, they're all called apple maggot flies. But I'm calling them hawthorn because if they lay their eggs on hawthorn, they're apple maggot flies that are from the hawthorn, etc., etc. And in fact, in fewer than 200 years, some genetic differences between the two groups have evolved. They're not yet different species, but they're very well on their way to becoming different species. It's speciation in progress. Okay, you happy with that? Okay, so that's sympatric speciation. It's quite difficult to understand why it would happen, but anyway, it does. And there's another example, yeah?
Does like speciation have to happen like between an organism or because like with horses, like can't you like breed different types of horses?
Yes, so they're not different species. It's like dogs, they're all the same species.
Oh.
They can all mate with each other.
So what makes a different species? Like do they have to
When they're so different from each other that they're unable to produce fertile offspring if they do mate, or they might not even be able to mate, then they're a different species.
okay.
Okay, all right. A second example of sympatric speciation is orca whales. Now you know that orca whales are killer whales, and a lot of them live, I'll just add to my map. Okay, so,
Okay. So is it like how we can't make babies with a monkey?
absolutely,
Okay.
but we can make babies with other humans. All
Wait,
humans.
Madam, isn't it only within the same species?
What?
The allopatric speciation and the sympatric speciation, isn't it between organisms of the same species?
But now they're separate species because they can't mate anymore.
So
These two are put together with each other. They can't mate anymore because they don't recognize each other's courtship behaviors. So they're reproductively isolated, they're different species.
Oh, okay.
Okay, so looking at the orcas, orca whales basically, these two particular groups live, so there's Alaska, live in this area. And there are two different groups of orca whales. There are residents and there are transients. So the resident orca whales live there all year round. The transient migrate. So sometimes they live up in the northern waters and then they migrate down and they come down to here, to the water, southern waters, and then later on in the year they go back up and down and up and down. So they cross paths all the time. Resident are there, transient pass through. They are the same species as each other, but they have changed so much that they no longer have the same reproductive behaviors. So they actually are now eating different food, and they have different social structures within the group, and they have different sounds. So they no longer have the same calls. They're not recognizing each other anymore. And if they don't recognize each other anymore, they're reproductively isolated, and they're becoming different species. Yeah.
Physically, are they the same? Like if you never hear their sound, you never hear anything. Like
Physically, they are similar, but they're differing. They're working their way to being different.
oh, okay.
Okay, does that make sense? So it's sympatric because there's no geographic barrier between the groups. The groups can mingle. Okay, they just don't recognize each other as being potential partners. Okay, right. So there are other ways in which sympatric speciation can occur. For example, hybridization and polyploidy, which we spoke about in the previous section. But we're not going to get obsessed about that. Okay. Right, you may have 1 minute to squirm and breathe. Who still needed these little ones? Here are some more little ones. We had enough examples of the big ones? Hey? You got 2. Step away from him.
Yes,
Shall God have what? You got?
Yes,
Yes, I got something.
What is that?
it's just peanuts now. Close in this one.
Rams like don't be so.
Oh, I thought at least it was going to be cashew nuts. Or almonds. Not at all. Peanuts are not to be sneered at. Honestly.
Are there other like animals that have pets?
When I That's a good question though. I've never thought about it. No, yeah, the birds, yeah.
Yeah, pets actually answer something.
What?
Did I take notes?
Like, you asked them pets, right? Like, you know, buffaloes, those,
Oxpeckers.
oxpeckers, yeah.
They're not pets. Termites farm.
Hippo, yeah, hippo.
So termites farm mushrooms underground in the termite gardens. So they bring grass from the top, and they bring it down and they chew a little bit so that it becomes soggy, and they grow mushrooms on there, and then they eat mushrooms.
How do you know our farm? Is it just natural?
I guess it's evolved over time. Yeah, it's amazing.
Actually, it's more space.
Many things are amazing.
Or like animals conscious that they are
I think so. Okay. No, just don't go too close to her. That's all I'm looking at. I promise you. Hello, Tahir. How are you? I'm fine, thank you. I haven't seen you for ages. Now, Tamlin was here a moment ago, and now she's disappeared. Oh, I understand. Okay. Have you managed to keep up though? Yeah, I'm listening.
So just quickly, while we have, I wanted to ask if there's anything which you can, like, give us a bit more focus points, I guess, for the test on Friday.
No.
I'm
so sorry. No. No. Sorry. I really don't think there's anything that would sort of be left out, because generally when we set a test like that, what we'll do is write at the top, settle the long questions first, and what we don't ask in the long questions, we ask in the short.
Okay, so that's still like,
Yeah. Sorry, my angel. So I'm not certain how Mrs. Lorenz is going to do it, because she set it. So generally speaking, what we do is we send out the test in advance, like a password protected test, or a test that is only opens at a test that only opens at like 2 minutes before you're meant to write it, or 10 minutes before you're meant to write it, so you can print it if you want, or you don't have to print it. If it's a password protected test, they'll send you the password at the exact time. Then you open the test, you write it, and you scan it with your phone and submit a scanned document or a photographed document. But it's absolutely up to Ms. Lorenza. She will tell you how she wants to do it. And my impression is she's going to ask you to do it on an answer sheet, where you can either print the answer sheet and write, or you can type onto the answer sheet and submit it as like a Word document. Okay. All right. Okay, guys, come. Let's go. Go. Okay, so just briefly talking about the test. Yeah. Are you guys all coming to school to write the test?
Yes.
Okay. So the test, you will be given an answer sheet. So it's got the question numbers and then lines on which you write the answers. Simply so that it's easier to actually mark for the online kids, because the online kids are a complete nightmare in general. Not you guys. No, the grade 8s wrote a cycle test on Friday. Friday last week. 2 of them submitted their answers as a movie. As a movie.
I can guess the name.
So there the answers just go zoom, 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 and I'm going, I'm saying very rude words. And when I say fix this, they go, I don't know how to.
Yeah.
No, really, no. 9 hours on Friday we spent trying to sort out their answers. I still finished. You know how I normally mark tests over a night by the next day? I had spent 4.5 days marking those grade 8 things, because they're also strange. Very strange. Okay. All right. You need to focus and understand this. It's called patterns of macroevolution. Remember, macroevolution is when organisms in one species evolve to another species. And there are 2 different patterns if you look at the pattern of, and this is not going to make sense until I show you the actual drawings. So they are called Anagenesis and Cladogenesis, and let me explain. So anagenesis is the gradual evolution of one species to another species to another to another. This no longer exists, this no longer exists, this no longer exists, this one exists. Okay, all right, that's anagenesis. Cladogenesis is when one species gives rise to 2 different species, which give rise to other species and whatever. So this is a branching pattern, and this is a more gradual pattern. So two main patterns of evolution, anagenesis, cladogenesis. Okay. So anagenesis is the gradual evolution of a species that continues to exist as an interbreeding population but eventually becomes a different species. Cladogenesis, a branching or splitting leading to two or more lineages and resulting in separate species. So this species evolves into that species. For a time, both still exist, and eventually this no longer exists and becomes that species, which becomes that species, which becomes that. Cladogenesis is a branching. So one species gives rise to two or more species. Okay, right. Anagenesis is quite a blurring kind of evolution, and cladogenesis is a branching kind of evolution. Okay. So anagenesis is an accumulation of changes that gradually change a species into a species with different characteristics, and therefore these ones will eventually no longer be able to interbreed with those ones, or these ones will have died out completely, and then may evolve into another species. Ketogenesis, one species splits into two distinctly different species. And this is more important in evolution than anagenesis, leads to biological diversity, and it is branching evolution. And so it would be like this. Okay. So if you compare them, this would be anagenesis, but that would be cladogenesis if you compare the two. Okay. I wouldn't obsess about these. I really think if they ask you just one question or one word, it might be a lot. But watch you guys get this big whack question out of 30 marks this year or something. They've never really asked it before. They might ask it as a one-word thing. What pattern of evolution is it? And your way of remembering it would be, do you remember a cladogram?
Yeah.
Being like that? It branches. So the cladogenesis one is a branching. And the anagenesis one is the blurring one. Okay. Right. Rates of evolutionary change, and this relates to anagenesis and cladogenesis. Gradualism and punctuated equilibrium. Okay. So gradualism is mostly by anagenesis. Punctuated equilibrium is by cladogenesis. It's more in a very short period of time. There's quite a lot of speciation. Okay, so gradualism occurs at a steady rate. It's quite slow. The species undergoes gradual changes. As the environment changes, those better suited to the changes pass their genes on to the next generation, and changes accumulate until reproduction with the original species is not possible. So gradualism is gradualism is a rate, but the pattern is anagenesis. The pattern is anagenesis, the rate is gradualism. Okay, so this would be gradualism. Punctuated equilibrium. Species show evolutionary change in sudden bursts that occur with long periods of time with little or no change in between. Rare and rapid events of branching speciation occur to form new species, and so this is linked with cladogenesis. Okay, so this would be punctuated equilibrium. Sudden bursts of speciation. Okay. I'm just going to explain this to you quickly, and then we can actually do the simulation next lesson. So a very classic example of natural selection is the example of something called a peppered moth. Now there are two forms of the moth that we are going to talk about. They're actually in between forms as well. So there is the melanistic form that is this color, and then there is the light form, which is this color. Okay, which is basically salt and pepper, speckled grey, darker speckles. And if you look at them on the bark of a tree, here is speckled one. You used to be able to see it. It was there. There's the body, there's a wing, and there's a wing. And there's the melanistic form. So on a tree that's got lots of lichen, you guys know what lichen is. On a tree that has got lots of lichen, speckled or light form is camouflaged and the melanistic or dark form is obvious. On a tree which has very little lichen, dark form is camouflaged and light form is very obvious. Okay, you happy with that? And so, if you look at this historically, the story behind it goes, these moths live naturally in Britain. Okay, and so many hundreds of years ago, there used to be many of the light form and very few of the dark form. Now they mutate naturally into either form. Okay, so every now and again a dark form would appear, and because it was obvious on the bark of the trees, the dark form was visible to the birds that eat moths, and this one was the one that was eaten. And so the numbers of this one were kept low. The numbers of this one were much higher. And then along came the Industrial Revolution, where there were lots of factories and things like that, and so there was lots of pollution. Lichen is very harmed by pollution. And so most of the lichen on the trees died, and so most of the trees only had their natural dark bark. There was no lichen covering them. And all of a sudden, the ratios of dark and light changed completely. Because now, all of a sudden, the light forms are the ones that are visible and eaten by the birds, and the dark forms are the camouflaged ones. So for hundreds of years after the Industrial Revolution, it was very rare to see a light form, and it was more common to have the dark form. And then in the 1970s, along came all the environmentalists who went, no pollution, whatever. The pollution laws were brought in. Factories had to filter their emissions from their chimneys, etc. And over time, what has happened is the trees have developed lichen again. And there's a reversion from this ratio back to this ratio. And studies have been done for a very long period of time on the relative numbers of the two different forms of moth. And there's very good evidence, there's good data which shows that this has happened. And so this is an example of, here, this is the fitter form, and that's the less fit, and it's the opposite way around there. Okay. Right guys, be good. Bongo, come and do your thing.
End of last half hour. Yeah, 22nd of July, it's off this too.